All right, mathletes, here we are problem solving using Pythagoras. So there's kind of 6 steps you're going to want to follow when trying to problem solve using Pythagoras. Okay, first step is draw a neat picture. Try and label all important facts. The labeling part, marked out on all lengths and the right triangle where it's present on the diagram. So putting the little box in the corner, that's a 90-degree angle, can be important. Use symbols such as X of size that you might want to solve for. Apply your Pythagorean theorem, which we know is a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. Okay, solve for your missing part, and where necessary, write your answer in complete sentence, and also remember units. Okay, so when looking at problem solving, a lot of times you're dealing with different shapes that aren't necessarily right triangles, but those shapes can be made up of right triangles. So these 5 are ones that you should be familiar with. Remember, a rectangle can be made into 2 congruent right triangles. One triangle here, okay, and your other triangle, the other half. So knowing that your diagonal of that is your hypotenuse of your right triangle. A square has multiple right triangles in it. You will have this one, which is the diagonal, is your hypotenuse in a right triangle. And then you could also have these 4 smaller ones, okay, in the inside. And these are nice because they're congruent here and here, and the right angles here. So the legs are half of your diagonal and they're congruent, and your hypotenuse is actually the side of your square. The rhombus, you can think of it as 4 right-angled triangles reflected over each other. Okay? An isosceles triangle can just be split down the middle and create 2 right triangles, one here, and they're congruent as well. Okay? And then we can also think of our equilateral triangle. Equilateral triangle is just a more specific type of isosceles triangle, so we could have 2 right triangles there. So know that we can break them down sometimes. Okay, so in this example, a rhombus has a diagonal of 6 centimeters and 8 centimeters. Okay, find the length. So first thing I do is I have my sketch of a rhombus. Okay, I know my diagonals. I have 2. My shorter one, 6 centimeters, and my longer one is 8 centimeters. Okay, find the length of its side. I label one of the sides as X. Okay, so as I break it down, where are my right triangles? Well, when again, the rhombus, we have right triangles here, and they're all congruent. Okay, and before I can apply my Pythagorean theorem, I need to know that these diagonals bisect each other. So because they bisect each other, this whole diagonal that was 6, this piece is 3, and this piece is 3 centimeters as well. If this entire length from here to here is 8, well, this piece is 4 centimeters, and this piece here is 4 centimeters. So if I redraw my triangle here, in the blue, I have my right angle here, my X here, 4 here, and 3 here. So if I want to solve for my X now, okay, I notice that X is the hypotenuse, so that's left by itself, and I have 3 squared plus 4 squared. Well, I'm in luck. This is a Pythagorean triple, because I know that 3 squared is 9, 4 squared is 16. This is equal to X squared. 9 and 16 is 25, and that's X squared, so X is equal to 5. Again, we remember that 3, 4, 5 is a Pythagorean triple that we'll see quite often with our right triangles. Okay, let's look at another example here. So this is find the length of a truss AB if the given roof structure. So we have a given roof structure. We're 20 meters across. So these trusses, okay, from A to B, they're congruent from here. So what we have is a isosceles triangle. We have 2 congruent right triangles. So I can see my right triangle is there, and my unknown, my AB is my x here. So I got a diagram. I labeled my unknown. I got to recognize that since this is a isosceles triangle, it's cut it in half. So if the full length's 20, this length is 10 meters there. So I redraw my right triangle and kind of pull it out. I have a right angle here. X is there, 4 is there, 10 is there. Okay. Again, my hypotenuse is my unknown, so that's going to be left by itself. That's equal to 4 squared plus 10 squared. Well, 4 squared is 16, 10 squared is 100, which is equal to x squared. And I get 116 is equal to x squared. Square root both sides. I get the square root of 116 is equal to x. And this is going to be approximately equal to, if I put it into my calculator, about 10.8, and then I'm dealing with meters. Okay, so that is the length of that truss. Let's look at another example here. Okay, so this one's dealing with navigation. So when we're dealing with navigation, we got to kind of remember that our north, east, west, and south lines are perpendicular to ourselves. So typically when we draw them on a two-dimensional plane, we have north being up, east being to the right, west being to the left, and south being on the bottom. So drawing that will help us deal with any navigation type problem. So a yacht sails 23 kilometers south. So if we call this the starting point, the yacht's going to sail 23 kilometers south. So label that. Okay. And then 18 kilometers due east. So then it's going to sail to here, and that's 18 kilometers due east. How far is the yacht from the starting point? So since it's made a right angle, the starting point is right here. So what is this distance? X. So again, our southeast bearing will create a right angle there. So if I kind of redraw my right triangle here, I see that I know that this is 23, this is 18, and this is my x. So again, my unknown is my hypotenuse. Okay, so I'm going to solve this as 23 squared plus 18 squared equals x squared. 23 squared is 529. 18 squared is 324 equals x squared. Sum those up, and I get 853 equals x squared. Square root of 853 is equal to x. Okay, and if I want to approximate that, I get square root. Put that into my calculator of 853, and I get approximately 29.2 kilometers from the start. Okay. So let's look at one final example here. So a man and his son both leave point A at the same time. The man rides his bicycle due east at 16 kilometers an hour. The son rides his bicycle due south at 20 kilometers per hour. How far apart are they after 4 hours? So again, I'm dealing with a navigation problem, so I'm going to draw north, south, east, west. Okay? A man and his son both leave from point A. So let's put point A right here. Okay? So they're traveling at a certain speed at a given for a given time. So I want to calculate the total distance they do. So let's talk about the man first. The man rides his bicycle due east at 16 kilometers per hour. Okay, we are riding for 4 hours. So a total distance that they have gone is 64 kilometers. Okay, the sun. Okay, so let's go back to the before we do sun. So that he went due east. So due east, guy rides out here, stops. That's 64 kilometers there. Now the sun rides his bicycle due south at 20 kilometers per hour. Younger, faster. Okay? How far apart are they? So again, he rode for 4 hours as well. Okay? So when we multiply this out, we see that the sun went 80 kilometers, but the sun went due south. So from point A, right here, we went 80 kilometers. Okay? So how far apart after 4 hours? So there, and then there we can see our right triangle. So I redraw my right triangle. I have 64, 80, and x. So again, I have 64 squared plus 80 squared equals x squared. Okay? 64 squared is 4,096. 80 squared is 6,400 is equal to x squared. We add those together and we get 10,496 equals x squared. So then the square root of 10,496 is equal to x. Well, that's exact. Then I'm going to approximate it by putting into my calculator. So I get the square root of 10,496, and I get about 102.4 kilometers apart. Okay. That concludes our notes for tonight. Please highlight any questions you might have and bring them to class tomorrow.